So, this is the second half of 12.1. The first half, we only focused on finding the missing hypotenuse. But now we're going to look at finding the missing leg. So, let's take a look at this triangle here. Some of you may recognize this triangle, right? Anyone remember what type of triangle this here is? Azalea, you remember? A right triangle, perfect. Does anyone remember what kind of special right triangle this is called? Victor, you remember? Acute, very nice. An acute triangle would actually be one with a smaller angle than this one here, but great. I'm glad you remember acute triangles. You remember? 90-degree angle, good, yeah, right angle. This is called a 3-4-5 triangle. That's what I was looking for. It was in the Ed puzzle they talked about, and it was on the worksheet we talked about yesterday, but it's okay. A 3-4-5 triangle. We're going to prove, basically, that it is that special type of triangle by using the Pythagorean theorem. Can I get someone to read this quick little sentence here? Jordan, go for it.
Okay. Along with finding a missing hypotenuse, we can also use the
Pythagorean
theorem to find the length of a missing leg.
Perfect. So, thank you, Jordan. If we take a look at this triangle here, who can tell me what is the length of our hypotenuse?
5.
I heard someone say 5. Give me a thumbs up if you agree with that our hypotenuse length is 5. Good. I see a couple thumbs up. Now, we know that our hypotenuse is the longest side of a triangle, right? But if we don't know how long this side is, how can we be confident that 5 is in fact our hypotenuse? How do we know? If we don't know what the third side is, how can we be sure that 5 is our longest side?
So close.
Sorry. Yeah. You remember, Azalea?
Yeah.
Oh, okay. What's up? Sorry, I forgot what the question was. What did I ask?
Why is 5?
Oh, that's right. How do we know that 5 is our hypotenuse if we don't know what all the side lengths are, Azalea?
Because it's like across from the C, which is
Bingo. And I know, Theo, you had the same answer, right?
Yes.
Right, there we go. It's directly across from the right angle. Take a look at this little box here that signifies that we have a right angle. If we think about that little box as an arrow, the arrow is always going to point to our hypotenuse. Right? It's kind of like a translation. If we just translate that box to the left and up, we see that it's pointing right to our hypotenuse. So even though we don't technically know all 3 side lengths, we do know for sure that the length of our hypotenuse is 5. And we also know what one of the leg lengths is, right? What's one of our legs' lengths? 4, exactly. 4. And what we need to find is our missing leg length right there, right? We don't know what this length is. We're going to have to find out. So we're going to do the same thing that we did when we were missing a hypotenuse. We're going to take the 2 numbers that we do have, and we're going to plug them in. All right? Can you guys do me a quick favor here? I accidentally messed up the letters just a tiny little bit. Can you scratch out the B and the A and just flip them? Have B on this bottom left corner, A up in the top of our triangle. It's my fault. I apologize, but there's our triangle ABC. So if we look across angle A, here's angle A. If we look directly across, we get side length A, lowercase a this time, which is 4. So we're going to take A squared plus B squared equals C squared. And for A, we're going to plug in 4. And we take a look at our angle B. We look directly across this triangle to the other side, and we see there's our side length B. Now we don't know what B is equal to, right? That's what we're trying to find. So our B squared is just going to remain as B squared here. But we do know what our C is, right? We looked across from our right angle and saw that our hypotenuse had a length of 5. So C is going to get replaced with the number 5. Very similar to what we talked about 2 days ago, except we're plugging in A and C instead of plugging in A and B. Give me a thumbs up if you're with me so far on how we plugged in those two numbers here. Good. Now our goal here, our goal is to get B all by itself. So we're going to have to think back to our multi-step equations unit. I think it was unit 7, right before we did transformations. And we're going to have to think about getting B all by itself, using inverse operations, bringing certain terms over to another side of our equal sign. Let's go through that process now. So we've got 4 squared plus B squared equals 5 squared. 4 squared is just 4 times 4, right? And that gives us 16. 5 squared, well, that's just 5 times 5. That gives us 25. But B squared remains as B squared. Can't split that up at all, right? That's our variable that we're solving for. Now, if we want to get B all by itself, I'm going to go ahead and split my equal sign here, just like that. Just so I know which side I'm bringing which number over to. And if we want to get B by itself, what are we going to have to subtract from both sides here? Anybody see?
16.
16, exactly. We're going to subtract 16 from the left, and we're going to subtract 16 from the right. When we do that, 16 minus 16 cancels out. And 25 minus 16 gives us 9. So now all we're left with on the left is B squared. All we're left with on the right is B9. Our final step here is going to be to take the square root of both sides. Square root the left, square root the right. If we want to split these up, we see that on the left we've got B times B. And on the right we've got 9. I'm sorry. Messed that up already. Hold on. If we want to split 9 up, right, it's going to be 3 times 3. Sorry. Let me move this back a bit. So we've got on the left an identical pair of B's that gets brought out. And on the right we've got an identical pair of 3's that gets brought out. So we get B is equal to 3. What do we write after our 3, everybody? Units, exactly. We're still talking about distance, right? We're still talking about the length of a side of a triangle. And this is the length of our missing leg. As long as we don't forget units on the end. Now, obviously, it's not always going to come out nice and even like that. But whatever we can simplify once we get to the square root, that's just what we're going to do. We're going to simplify as much as we can. Give you guys a moment to finish getting that copy down. Yeah.
Yeah.
That's pretty much it. Are there any questions I can answer about how to find a missing leg? Little bit different process from what we talked about on Tuesday. Slightly different. We got to do a little bit of equation work, but if we remember how to subtract from both sides, we should be good to go. Now, if you want, if it makes it easier for you, actually, you know what? Never mind. Well, if we have time on Tuesday, we'll talk about a shortcut, but this is what I want you guys to do here for this.